welcome to my desktop. So I was at the, what do you call it, panel for the HPC yesterday, and someone brought up the challenge of getting people to start using HPC more, or getting adoption there. I think that's really important. Does anyone remember SETI at Home? Berkeley Open Infrastructure for Network Computing, that sort of tool. Telling these stories is really important if you want to get the adoption stuff. So I'm going to show you something that's definitely not ready to be shown, but there's stuff here. And it helps tell the story of Julia, the evolution of it, the use of it in research. My name is John. I am with NumFocus. I am also the executive director at the Open Source Endowment. Happy to talk about either of those separate from this. So we've built a map. This is the Julia ecosystem. I can't move this around that much or it will break my computer right now. But you can see I probably chose the wrong colors, but you've got blues are people and the purples are repositories. And I haven't put any of the other nodes on here because that also will, there we go, break my computer. There are edges in here, so we're starting to see the relationships of the ecosystem. This is the sort of end state that we're going to try and get to make this much more easier to use. But what did we do to get here? And then I do have data in tables that is probably exciting. And it just got brighter. It sometimes does stuff that's very exciting. All right, so this is the map of open source science. Essentially what we're doing is connecting the people, projects, papers, and institutions in any ecosystem to one another. So we can see what's going on. We can see who's using stuff. We can see who's contributing to what projects. We can see what projects are being used to create economic output, and then we can use that to go tell a story to a funder or to a government to try and get things like the Sovereign Tech Fund and Sovereign Tech Agency built around the world. And so we did that with Julia, we being me. What I did is a query on GitHub, essentially. So we ingest a bunch of repositories. So we look for Julia repositories that have 10 or more stars, simply because we can't ingest, I think it's like 40 or 50,000 repositories right now. And once you ingest these into this database, you're able to explore one. Let's see if it will load. I'm tethered on my phone, which is back there right now, so it might not. Hey. And you can get a bunch of details about the repo. Many of these are probably not accurate right now. You can explore off GitHub, all that fun stuff. You can also extract DOIs. We'll come back to that in a second. We can also ingest publications. So a publication, we take the DOI, we bring it into the database. I think I have one of these preloaded. Once it's in the database, you have a whole bunch of information about it. Authors, institutions didn't work, et cetera. But you can see the citations, references, impact, and we can do a lot of stuff. Once the data is in this database, we can play around with it and get some pretty interesting insights. Okay, so here's that batch ingestion. So we search for Julia with more than 10 stars. We find 6,000 repositories. We bring them all in, and then we can extract all the DOIs from all of these repositories and then do an analysis on those DOIs. That analysis, apologies for the telegram, can take place in 3 levels because this is essentially a citation graph. It's a lot of data. So you can do the level 1 where you take your seed work, you have one DOI, one publication. From that one publication, you get all the authors, all the institutions, and all the topics. So we're essentially going from GitHub with a repository that has a DOI in it, the citing DOI, the reference, the canonical DOI of that repository, or something else. But hopefully we found the canonical one. Little side note, we can't use Zenodo right now because its API is very difficult to use. So we can only use reference papers, which kind of sucks. So we go from GitHub to OpenAlex with that DOI. If you don't know OpenAlex, check it out. It's a fantastic resource. OpenAlex categorizes publications based on a hierarchy that goes from a topic, which is basically one topic per publication. Sometimes there's 2. Sometimes a topic duplicates across publications, but for the most part, they're unique to each publication. Topics are assigned to subfields, then fields, and then domains. So when you take your seed DOI, you get the authors, institutions, and the topics that that publication is associated with. Then you get the references, the papers that this seed DOI references, and the papers that cite this seed DOI, and you make little placeholders in the database. That's a really easy ingestion to run. Then we do a level 1, or a 1 depth, where you take that same data, and then you do this process, the authors, institutions, topics, with all the references and with all the citations. So now you've just exploded to several tens of thousands of papers, and with Julia, it's actually a couple, I think it's 150,000, we'll see in a second. And then depth 2, I've not tried to run one of these because you essentially do that same thing again with the papers that cite the papers that cite the, et cetera. It goes on forever. So you're building a giant citation graph. So I did a depth 1 ingestion of the Julia repositories, the 6,000 repositories that we brought in. That resulted in this database with 155,000 works, 11,000 people. So these are the people that contribute to the projects from GitHub, and also who are the authors to the papers that are referring to those projects on GitHub. And then the 650 institutions, these are the institutions of those authors, because OpenAlex also has that data. So essentially, 650 institutions around the world are using Julia. That's fun. So with this data now, we get some fun tables. Julia is used primarily in the physical sciences. You can see 1,201 works there. And we can keep going down this. We go to top fields. So fields, there's a bunch more fields, not nearly as many as topics, you'll see in a second. Engineering, or medicine, engineering, social sciences, et cetera. I can share this data with anyone who wants to see it. Subfields, molecular biology, and so forth. And then topics, like I was saying, there's really one topic per publication. So what does this look like over time? Like this. So you can see medicine has been adopting Julia, or papers, more papers are being published that use Julia projects since its inception, et cetera. A lot of this data is fuzzy, but it's mostly, the trends are mostly accurate, and so forth. So I'll leave this up for just a second. So you can see it, and we can see where we're at right now. And so the point of this whole tool is to help us tell the stories of open source software. Julia is a language that's evolving. It would be pretty neat to be able to see this tool out there more, or more tools like this. There's also projects like Chaos that do health metrics, which this tool can do, but I can't show it right now because it's not really implemented. But utility analysis, impact analysis, things like that across the whole ecosystem. And what can happen with this is we can put Julia and Python next to each other, and we can see where they intersect. And we can say who's contributing to both ecosystems. And then ecosystems can start to support each other and really weave a deeper connection and a healthier open source world. So with that, I just asked AI, Gemini in this case, if it would be possible to build Boink on Julia. And of course, it's very optimistic, so it says, yeah, you should just do it. But this is maybe not a crazy thought. If we need to tell stories of these projects, of the software, to people who don't understand the software, I'm very much in the middle of that. A lot of the stuff, I'm out of my element here, I can tell you right now. Garbage collection for me happens on Thursdays. But if we need to tell these stories, we need the tools to tell these stories so that people can recognize why these tools, the underlying tools, why the software is important. And maybe something, I know Julia is great with distributed computing, maybe something like a publicly accessible distributed computing network would be awesome. I know Boink is very much used today. I've built a couple organizations around it. It's fantastic. It's exaflops of processing power. This is way off base though, so I'll stop here. If anyone's interested in learning more about this project or seeing any of the tables, let me know. If anyone wants to help build this thing right now, it's just me, and I am not very good at software, so would love help. Thank you.
Thank you, John. We have time for a quick question. Thank you. This will be already very useful for me when I'm submitting for grants. I'm curious, the plot of papers over time, I was very surprised to see like 50 papers in 2012. Like, was Julia really useful back then?
So that's the fuzzy nature of the current database. There was a bug I did not catch when I was ingesting the DOIs. So it recognized some of the papers that were referenced by the early Julia papers as Julia papers. So it actually goes all the way back to like 1988. It's like, oh, well, that's not right.
I see. Thank you. Any more questions? Thank you, John.